Okay, when we left off in the last video, we had made a working basic Markdown file for a numeric entry type problem that we could convert to PrairieLearn format and run and test. So before we get into adding some of these new features I was talking about in the last video, I wanted to just go over a couple of things that I did wrong. So we're trying to come up with a bit of a standard way of filling in some of the fields here in the preamble, and one of them is the topic. So if you were to go to, say, GitHub and go to the open resources repository, there is a learning outcomes link here, and inside here you'll find master list. And it's a big table, and it has topics and subtopics and learning outcomes listed here. And in fact, if you were to, let's see, I think you've got to go all the way to the bottom here, and then you scroll to the right, there's some codes in here. So what we're going to try to do is we're trying to use something that's listed as a topic here in the topic field. And so we'll scroll through all of this stuff. All of these topics are relevant to the first year physics course. Then it gets into fluids and oscillation waves, thermodynamics. So here, electrostatics and magnetism, that's where we are. And we're going to pick something from the magnetism topic. So we will go back here and change this to magnetism. Another field that we're trying to standardize is the source, and that's because we may decide to update the attribution and include links to like the relevant chapter of a problem. And so the format is going to be the volume dot, and so we're working with volume 2 of the OpenStax book, then chapter, and we're working in chapter 12, and the problem number is 55 for us. Okay. The other thing we could do is we can update the outcomes, and we're going to use the same table we were looking at before, and we'll just go through these magnetism topics and figure out which ones are relevant. And so magnetic field is a little bit vague. Magnetic field lines. Motion of a charged particle in a magnetic field is relevant. They seem to have 2 of those there. Because in our problem, we've got an electron moving in a circle inside a solenoid. And so that's a particle moving in a magnetic field. And so maybe we'll copy this code and we'll put it into our learning outcomes. And I don't know, I guess we might as well, put in the other number as well. And then we could just go back and see if there's others that are also relevant. Motion of a charged particle, we got that. Magnetic field produced by electric currents. That's not really like an Ampere's law type thing. That's not the focus of our problem, although it is a little bit relevant. Magnetic force on a moving charge. Okay, so that's relevant. So we'll take that one again. They've got 2 numbers there, so I guess we can put them both in. And we go back and keep looking at the subtopics here. Magnetic force on a current carrying wire, nope. And torque, nope. I did see solenoids in here, and so our problem does have a solenoid, so we can pick that one. Okay, I'll put those solenoid ones in there, and then we'll have a quick look here. Magnetic flux, induction, no. Okay, so that's good. So we've got our topics listed and our outcomes listed. Okay, good. So that's where we are in our problem. Let's go and look at the actual problem here. I'll make a new variant. And so remember, one of the issues was that we had lots of zeros after the decimal place sometimes, and we fixed that with formatting the number. So let's see if we can identify some other issues. So I'll just enter anything here. And the correct answer comes out with a ridiculous number of decimal places. And we could fix that by re-expressing this either as a float where we specify how many numbers are going to follow the decimal point, or by expressing this in scientific notation. So this is what, like 40 milliamps, and if we make a new variant, then we get 0.8 milliamps, and so maybe it's better to just express this as in scientific notation. Now, remember in the last video we did try to format this using this kind of notation, and we got an error because what that does is it converts the number into a string, which PrairieLearn didn't like for the purposes of grading. But there is something we can do, and so we're going to make another note to ourselves, and let's say we're going to write the solution formatted using scientific notation while keeping 3 sig figs. Okay. We'll copy a lot of what we have here, so we don't have to retype all of it. And we're only going to make a modification to this part of the problem, and so we're going to add an _str. So str stands for string, so we're going to write a string version of the correct answer. And we'll use some of this formatting notation that we've already used. We just have to make sure to put the I back in there. And now, if we want not to write just a float, but something in scientific notation, we change this F to an E. And if we keep 2 digits after the decimal place, we'll end up with 3 sig figs because we'll have 1 before the decimal place and 2 after. Okay, now what we need to do to make all of this work is we have to add in one of the customization options. And the option that we're going to use is show correct answer, which by default is true. We're going to set that to be false, so that if that's all we did, then when we ran the problem and submitted an answer, it wouldn't display the correct answer at all. So what we're going to do is we're going to replace that with our own correct answer. And so we're going to go down to this answer panel, and we're going to say we want the answer to be displayed as I is equal to, and then we're going to call this correct answers part 1 answer string. So it's correct answers dot part 1 underscore answer underscore string. And then we want to have some units, and so it's going to be expressed in amps. Okay, let's try this. Let's save it, and we'll go and convert it to PrairieLearn, and then we'll find those files and we'll copy them over here. And let's make a new variant of this problem now. And so let's enter some wrong answers. Okay, and so now our correct answer is nicely formatted. It doesn't have an absurd number of digits, and we always get something in scientific notation with 3 significant figures. So that was one issue that we could solve. Another one is if I was to enter some ridiculous answer into PrairieLearn. I don't know how many. What is this? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 2.1 and a bunch of other stuff times 10 to the 10. And if I save and grade this, it tells me what I submitted. And it's a big long number. It's very hard to read this. So I would prefer if this said what my submitted answer is in scientific notation if I write either a really big number or a really small number. Okay, and so we can implement that. And what we're going to do is we're going to make use of some of these fields here that we haven't done anything with. And I'm not going to type this all out. I'm going to copy it from something I have off screen here. And I'm going to paste it into here. I'm going to paste it into parse. What parse does is it finds the answers that were submitted so that you can do some manipulations with them. And so this is going to call, this PBH is, I forget, problem bank helpers. Okay. And so there are some scripts that contain functions that will take some arguments and return something. And so what this particular one does is it takes the submitted answers, checks to see if it would be a good idea to re-express it in scientific notation. And if that is a good idea, it will return the number expressed in scientific notation to be written to the submitted answers field. Okay, and so that's all we do. That's all we do is we just copy this. We don't have to make any changes to it. We do have to add something to the submission panel. And the submission panel, what we're going to do is we're going to say submitted answers dot part 1 answer string. So that's what that function will return. Okay, and so that's all we have to do. We could do this for all numeric entry problems if we want to. The syntax doesn't change. Hopefully this is going to work, so I'm going to save that. Let's reconvert the files, copy them, and paste them into here. And let's go see what kind of changes we have. So let's make a new variant. And now I'll enter some big number. Okay. So, oh, I know what I did. So, what we have to do is there's a couple things that we need to do. I think what we have to do is include a few things at the beginning of our code before the generate. So some of the stuff here that is required by that function is the part 1 answer, the symbol, and the units that we're going to use for our problem. So I think if we include this stuff here, some of this stuff here is not necessary for what we're doing right now, but it's going to be necessary in a second. So let's keep that there. So let's see if we include the stuff at the beginning, whether we will have fixed our problem. Okay, so let's get this question again, and let's enter in. Okay, here we go. So it says I got the wrong answer because I didn't enter in 4.5 times 10 to the minus 3. But it does tell me this is what PrairieLearn says I entered, and it's correct, but it's hard to read. So we added some extra text that says, in scientific notation, I equals 1.2 times 10 to the 6 amps was submitted. And so I think that's quite nice. Sometimes it's nice to have that on its own line. And so if you wanted to do that, you could enter a new paragraph. Okay, and so we'll see what that looks like in a second. All right. So let's say I entered 4.5 times 10 to the minus 1. Maybe 4.52 times 10 to the minus 1. So I got the coefficient right, but I got the exponent wrong. When I submit that, I'm just told that my answer is wrong, and that's it. In that case, it might be nice if we could check to see if the coefficient is correct, but the power is wrong. Maybe it's a factor of 10 or 1,000 if it's a unit error or something like that. So if I get it right, of course, it's graded as correct. Another common thing could be a sign error. And right now, if I enter a sign error, I just get that my answer that I submitted was wrong. So we can implement a simple check for simple types of errors. And so I'm going to copy over some stuff again. And now we're going to use this grade section. I'm just going to copy some stuff over here. I don't know why. These 3 lines are comments. I don't know why this one didn't come out orange. But nevertheless. So let's see if I can make it orange. I can. There we go. All right. So what we're going to do is we're going to add another function that again is in this problem bank helper file, and it's going to check for errors. So it'll check to see if the coefficient of the number entered is within 3% of the coefficient of the correct answer. If it is and the power is wrong, it will tell you to check your exponent. If you have a sign error, it'll tell you to check the sign of your answer. Okay, and so some of this stuff up here, error check equals true. If you want your error check to be enabled, that's necessary to have. If you want it to be disabled, you can just call it false or whatever you want. If it's not true, it won't do the error checking. And then you have to tell it the tolerance that you're willing to accept. And for now, this number should be equal to this number. It's a bit unfortunate that right now we have to enter that twice, but for now, that's what we need to do. Maybe that will change. Okay, good. And then the other thing that we will need to do is we're going to go back into the submitted answers part, and we're going to say feedback.part1 answer. And again, this syntax is the same for all numeric entry type problems. And so we can save this. There is nothing in that syntax specific to the current problem. And so we can copy this and bring it over here. Okay, let's make a new variant here, and let's enter a wrong answer. Okay, so here is the correct answer formatted in scientific notation. It's telling me that in scientific notation, this was the answer that was submitted, and it didn't do the error checking. Whoops, sorry. So now what I'm going to do is I'm going to try to enter 227. So I have the exponent wrong. So save and grade. And maybe did I not copy this over? I did. What happened? didn't work the way I thought it would. Let me check this out. Okay, let's go new variant. Let's just save and grade. And so let's go 524. Oh, here it is. Maybe I just missed it. Maybe it was there before. So it says check the exponent of I. Now, that's not in the right spot. That's why I didn't see it. Okay, I put this in the answer panel. I didn't want it in the answer panel. I wanted this in the submission panel. And moreover, I didn't want that new paragraph in the answer panel. I wanted that in the submission panel. Okay, let's try this. Sorry about that. Let's see if we can get this right. So I'll regenerate the PrairieLearn files. I'll copy them over. And let's make a new variant of this problem. Okay, good. So there's the correct answer in scientific notation. So let's enter 192. The power is wrong, but the coefficient's probably within 3% of the right answer. And I get a message that says I should check the exponent of I. Okay. And if I also had a sign error, it says check the sign and the exponent of I. So if I had the right exponent, but just the sign error, it says check the sign of I. And then finally, if I have everything right, okay, no, I don't have everything right yet. Here, if I have everything right now, then I get the correct answer. Okay, good. So that's all of the things that we can implement where we have formatted the display of the correct answer. We have formatted the display of the submitted answer. So if I submit an answer, it will decide to write it in scientific notation if the number is really small or really big, and we've implemented some error checking. And so that's all really good. One thing that I still don't like about this is that this attribution to OpenStax University Physics appears 3 times, and so that's just a little bit of a bug in our system. I can show you how to fix that. If you go into these files here and in fact press edit, if you take this part that's inside the Markdown, well, I don't know what they're called, but this Markdown part, and you put it all inside a PrairieLearn answer panel, that should fix the error. So let's save and sync, and let's go back to our question now. And oh, sorry, that didn't work. Oh, sorry, it's not an answer panel, of course. We want that to be in the question panel. I want the attribution to show up only in the question panel. That was silly. Okay, good. So save and sync. Let's try that again. And so there it is. There's the attribution inside the question. When I grade, it doesn't repeat here. And now if I put minus, I don't know, 161E3, we'll see all of our features at once. So the attribution's not repeated. Let's do this a little bit bigger. So the correct answer is formatted in scientific notation with the right number of sig figs. The answer I submitted is expressed in scientific notation. It tells me I got the sign wrong and my exponent wrong. And so those are all of the features that we have implemented now. And so of course, if I can get this right, we should just get our correct answer. Okay, good. And so that's a fully implemented numerical entry style problem. And I hope that this was helpful. Thank you very much.